Hello, welcome to the Edinburgh Science Festival, and thank you for joining me, Susan Morrison, at this wonderful event, 70% water, life aboard a research science ship. And if you've ever wondered what it's like to work on a research science ship, or you hope one day to explore the oceans aboard such a ship, now's your chance to ask questions of those very scientists. We'd like you to put your questions into the YouTube chat function, and we will pass them on to scientists actually at sea. Because later we are going to go ship to shore to the RRS Discovery live at sea and speak to the scientists who are exploring 70% of the world's surface, which is made of water. Now, there's a lot of water here. I am not an expert. I'm not the person that can tell you about how this is all explored. Fortunately, right next to me, I do have an expert right here. This is Lara Camden, and she has the most amazing job title. Your job title is Research Explorer. That is so cool. What is it that you research, Lara?
So, as Susan said, more than 2/3 of our planet is covered in water. And that's really important for whole numbers of aspects. Obviously, it has its completely own set of plants and animals who live there, because if you live in the water, most of you can't live on land. But the water itself is also very, very important and very complicated, because we all see the waves and the shore, but there's also motions on a much bigger scale. The whole ocean is sort of very slowly being stirred all the way around the world. And there are places where the water goes from the surface down 3, 4, 5, 6 kilometers to the bottom. And then, of course, places where it does the opposite. And that cycle and that motion is very, very important for climate effects. And then there's also an entire landscape under the oceans. We don't tend to think about it, but there are huge mountain ranges and vast empty plains and deep trenches. The tallest mountain, actually sort of base to top, is not Everest. Everest has a head start. It's the big island of Hawaii.
Hawaii?
Because
we only see the top bit.
We only see the top bit, and it's still tall enough to have had glaciers on it not that long ago, and it still gets snow. The only place on land I've been snowed out of fieldwork is on Hawaii.
If you're an oceanographer, that shouldn't be allowed.
Yeah, that was a little detour, shall we say. I saw better of it. You don't usually get snowed out on the bits of ocean that I go to.
And you collect samples, and it's you brought some of the samples that you've had with that you've collected, because
yes,
your interest is, if I may say so, and I don't want to sound slighting, rocks.
Rocks, yes.
Rocks, everybody. These are rocks.
Rocks and what's underneath the rocks and what they tell us about how our planet moves and where a lot of the earthquakes and volcanoes are. I mean, who doesn't like a good volcano?
Oh, well, personally, I'm terribly fond of a good volcano myself. I mean, but I would imagine that volcanoes are quite... Surely you can... Well, we can see volcanoes when they're on land, but how do you see a volcano under the water?
Well, so first, they do tend to be mountains. So first you try to find the mountains. Sometimes you don't quite know where the mountains are. The US Navy ran a submarine into one not that long ago. That was an expensive mistake.
Oops.
It was okay, like it was recoverable and nothing went into the water that shouldn't and nobody died. But nevertheless, rule number 1 of submarines, do not sail them into mountains.
Got that, everyone. Good tip there.
But sometimes you don't actually know they're erupting until you're a little bit closer than you really wanted to be. I was on a ship that was actually mapping a different line of volcanoes that are quite safely dead off New Zealand, but there's one nearby that's very active. And since we were nearby, we were going to go and do a little run over it and map it and see how it had grown or shrunk in the few years since a ship was last there to do this. So we were going along very nicely, making a map, and then we realized that dead in front of us, ships don't turn that quickly, we were going through it, there was an erupting volcano. This is bad for a couple of reasons.
A couple of reasons?
Well, 3 actually, so that's not quite a couple. One, well, the volcano might have grown, and so you might sort of run aground on it. Running your ship aground is bad in general. When it's on an erupting volcano, it's worse. It's sort of double jeopardy. Secondly, it might throw rocks at you.
Throw rocks at you?
Yes, well, so volcanoes, sometimes they erupt like the one in Iceland that you might have been watching on the cameras. There's some little lava fountaining, but mostly it flows down fairly tamely. Some eruptions are not like that. They pretty much the volcano explodes.
Okay, and chuck stuff at you.
And chucks stuff at you. And
So it's a pretty angry volcano.
that's bad. You know, if you have a volcano throwing rocks at you, that's bad, particularly when you're on a ship and if you get a hole in your ship. Well,
so many health and safety tips here about being at sea. If you want to know some more, don't forget to get your questions in the YouTube chat.
and then
Loads.
if the volcano is feeling a little bit more subtle, part of what makes the explosive eruptions is if there's a lot of gas in the eruption and the pressure goes off, the gas expands and things go pop very violently. But it can also just put so much gas into the water column that your ship no longer floats.
You're sailing on soda water.
Yes, only not on purpose.
Oh, not on purpose.
In this case, we were lucky, basically, and it wasn't shoaling, so it didn't run aground. It didn't throw rocks at us. And the patch was small enough that we weren't in it long enough to find out whether or not we would have floated in it. We didn't sail back through it a second time just to make sure.
These are all the exciting things that can happen to a scientist at sea. I think you should get your questions on YouTube so we can find out what else could happen to you on sea. Do get them in. I'll pass them on to Lara. Let's find out more. But you have got these samples. See me down with the scientific talk here. These samples. What's that one?
So this came up from an extinct volcano, nice safe one, off the eastern coast of Australia. And this is from one of those eruptions that the volcano was feeling a little bit grumpy and it threw its toys out of the pram. So this is one where it's a big explosion and you get this mixed flow. It's called a pyroclastic flow that is gas and ash and pieces of rock. And it all goes rushing down the hill. This is what it did for Pompeii. And it makes a big pile eventually. And initially, it's actually quite fluffy. There's lots of air in it. It's mostly made of a rock called pumice that if it hardens, you can actually make it float on water. You can play poo stones instead of poo sticks. But if you get a big pile of it, fluffy things when they're in a big pile, they sort of squish.
So far we've had soda water, seas and fluffy rocks. How much more thrilling can this all get?
So this is a collapsed pyroclastic flow, which once it's collapsed and turned into a rock, has another big long name. So that's an ignimbrite.
Ignimbrite. Okay. So this was a fluffy rock to start with. How do you?
It's not very fluffy now, is it?
No, it's not. If I were to throw this at Sean, for example, who's our technical helper, lovely, it would hurt. I'm telling you that here and now. It's not going to float off his buns, that's for sure. Now, pardon me for mentioning this, but this is a rock, and that is a rock, and that is a rock, and they come from the bottom of the sea.
Yes.
So I'm assuming you don't dive down to gather these by hand.
No. There are a few places where you can at least send a submersible down to do it. Santorini, quite good to send a submersible not too deep. The deeper the submersible goes, the more expensive it is. They like you to find alternatives. So one of the most common ways that you go for rocks is essentially you go fishing, only no one's figured out how to bait a hook for a rock yet.
Okay.
So could we see the dredge?
I love that title, The Dredge. It sounds a bit like, whoa.
So hanging in the air in the middle of this picture is a
Sort
dredge.
of basket thing.
Is the basket thing, and that is pretty much what it is. It's a mix of very high tech and very low tech, in that you have basically a giant chain basket made of metal. It's about 2 meters long all in, with a couple of tubes hanging off the bottom. Those are called the pipe dredges. Mm-hmm. And it's got a big metal mouth at the top. And it's
you just drag it along.
And so you find a likely looking spot, you throw it over, it's on a cable that's at least 5 and up to 10 kilometers long. That's actually more expensive than the metal basket, but it's not that easy to make a cable that long and strong. So you throw it down, you drag it up a nice slope. You hope it catches some rocks, even though it doesn't have any bait in it. You hope the pipe dredges catch some little things like sediment and just, smaller rocks. And then you pull it up and you see what you get. It's sort of fishing meets lucky dip.
So you might get something like this other kind of a rock. That one's slightly different.
This one is slightly different. This is from a nice well-behaved eruption. So this is a basalt. Same thing as Iceland is made of. One of the most common rocks for a volcano, particularly in the oceans.
Amazing. It looks a bit like quite expensive black pudding.
There's that.
I said quite expensive, as if I'm aware.
It came out as lava and cooled.
Why are there holes in it?
And there are holes because even a well-behaved eruption has a bit of gas in it. And so it has little bits of gas in it. As it comes up, the pressure reduces because it no longer has so much rock on top of its head. The gas expands and you get these little hollows. The little white spots actually used to be holes.
Oh, I see.
But they've since filled in with other minerals because it was under the ocean. There was a lot of seawater around. It was hot, so you get fluid flow from hot to cold. Rock was hot, ocean was cold. Get some fluid flow going, and you get other minerals growing from that will fill in the little holes called vesicles.
So this must tell you an amazing amount about volcanic activity and how the Earth was actually formed with its volcanic activity. Is that what that's a remarkable shade of green? I must admit.
Yes, we have a green rock. So this came from the same voyage, but from a slightly different location, a little bit further north, and that's near one of the places where you're getting a deep trench, a deep sea trench, a subduction zone, which is where one piece of yeah, that one's heavy. Sorry, should have warned you. I told you this was fluffy.
That was fluffy. This is not fluffy.
Not fluffy.
You drop this on your
fluffy.
toe, gonna hurt.
So anyway, that's from our trench, which is where one piece of the seafloor is going under another piece and will actually go all the way down into the earth and melt again.
Do you mean the Earth is green then, in the middle, do you think?
It is, yes. Well, not all the way in the middle when you're in the core, which is mostly made of iron, and iron is usually not green.
Yeah, because you know.
But the sort of middle bit, about 3,000 kilometres worth.
You wouldn't use the dredgy thing to get that, would you?
So we did get that with a dredge. So that's not actually the same green as the middle of the earth. That's a mineral called serpentinite. And that happened from the plate being bent. Because when you bend things, sometimes they crack. And if you crack something underwater, you get seawater flowing into it, and it went and turned what was one green mineral into a different green mineral.
It is really quite strangely... It is
green and kind of stripy.
Green and kind of stripy. But would you use something else to sort of like grab things from the bottom? Or do you because we've got the dredge, but that wouldn't work all the time, would it?
So the dredge is your best way for getting rocks in deep water other than this whole lucky dip, and you do have to expect that sometimes they're not feeling generous and you don't get anything back. But something that you use when you're on softer sediments and you want to get sand and mud and perhaps sample some of the life down there is we would use the grab. Can we see that grab? So this looks a bit like one of those grabby cranes that you get at an arcade or something going down for a cuddly toy. It has a higher success rate than the sorts you get in arcades, fortunately. But that is essentially how it works. You send it down with its little arms out. You get to the bottom, you aim at something nice and soft as opposed to something nice and hard. Arms come in, closes off the bottom. You pull it up, and then you dump it out into a tray and you see what you get. I did not bring any sand and mud because they're not really great to hand around.
No, run out your fingers. It's quite messy actually. But I mean, there are
So we do have
that looks a bit like a potato. Sorry.
Yeah, that one actually. This particular sample didn't come up in a grab. They do come up in grabs. This is in fact called a sea potato because the person who named it also thought it looked rather like a potato.
That technically makes me a scientist.
So that's a common one around the UK. You can find them washed up on the beach. It's a sea urchin.
I have seen,
I have
seen
a type of sea urchin.
So next time you're on a beach and if you see something that looks like this, I thought it was a crab. It's a sea potato. Don't forget to get your questions in, by the way. Use the YouTube chat function. And
so we do have these, which did come up in a Smith Mac grab, not actually the one pictured, because they came up in a UK one, and the one pictured is the Australian one. So we have these little shells that came up. This one is quite fun. It's called a pelican foot shell. I am not a good enough biologist to know if that foot bit looks more like a pelican's foot than another bird, but it does look rather like a bird foot.
If there are any ornithologists watching and you'd like to make, really, there are scientists out there who genuinely worry about this. Is this anything like a pelican's foot?
But it uses that bit to sort of dig up in the sediment and kind of toss it up and see if there's anything good to eat.
Well, I think it's very clever, whether or not it is a pelican's foot, quite frankly. So, and That looks like a little tiny unicorn horn.
Yes, little tiny unicorn horn. Again, often seen on the beach. Often not quite as old as this one. That's a common tower shell or common unicorn horn. And again, that came up
found them on rock pools.
in
Isn't
a grab.
that gorgeous? That's so pretty. It's actually quite strong. It's also quite sharp. I've just realised that. That's not. Is that coral?
And yes, this is a coral that was collected on a different UK research vessel, the RRS James Cook, off the Outer Hebrides.
Of the Outer Hebrides?
Yes.
I thought we only got coral in exciting places like Australia. Oh my God, it's heavier and stronger than I expected. I thought coral was quite delicate.
Well, the living organisms on it are quite delicate, and you get some forms that are a little more, but it is effectively made of rock.
Okay, so Kat has just sent a question in. Hi, Kat. Where is the most fascinating place you have visited as part of your research?
I think that probably the most exciting has been the work off Australia, because that's asking some really big questions about how the interior of our planet works, which is that we know we get a few spots that are like Hawaii, where you get a nice line of volcanoes, and they're all in age order, very nicely lined up, which has been explained for 50 odd years as you have warm material coming up from deep in the Earth's mantle, it burns a hole in the plate, makes a volcano, the plate moves, it burns another hole. But there aren't quite enough of them. We've lost some somewhere. Because we know that there's a certain amount going down at these trenches that we talked about earlier, and the Earth is neither shrinking nor growing, so you need to have the same amount coming up as you have going down. And we don't have very many places that you get these lines of volcanoes that really fit the model. And Australia has these 3 chains of volcanoes, 1 on land, 2 in the ocean, that almost fit the model. Except there are 3 of them, not very far apart, and they are flying in formation, or they were till about 6 million years ago. And so it's a tantalizing question of, is it that our model is a little bit too specific? Can we figure out how we sort of adjust it around the edges so that it's still stuff coming up, but it isn't just one line poking holes. It can do other wild and weird things like fly in formation.
Oh, there are still many, many things to be asked. And very quickly, because I want to ask you about sharks in a second, what's the most unexpected thing you've ever retrieved from the seafloor? I found £20 in a rock pool once. Would that count?
Yes, it's just about the seafloor for sort of a miniature sea. I think the most expected, actually, can we go to the tiny ship crystal? So this is from a project that actually had a core drilling rig so that you could not just drag a dredge up. You could instead send a rock drill down to drill out a cylinder of rock. And the guys who can do this are amazing, because you make a hole, you have to take it up. Rocks are quite hard on drill bits, oddly enough. You have to replace the bit, and then you have to get, 1.5 kilometers of water. You have to get back in a hole this big, and you can only move the drill bit by moving the whole ship. So anyway, you do it, and you can get rocks, and you can look at rocks under the microscope. So this is a basalt, a bit like this one, only hadn't seen as much seawater, under a special microscope. And you can see there's a little tiny ship there. That's made of crystals of a quite common mineral called plagioclase. And we were just also tickled when we found it. It was like the volcano had a sense of humour. We were there on a ship taking its rocks, and it had supplied a little miniature of our ship to us.
It's all going on, isn't it? Now we've got vanishing volcanoes and comedian volcanoes. It's incredibly busy. But you're on a ship when you do this, and we have got the most fantastic piece of footage introducing one of the ships that's out there carrying out this incredible work, the RRS Discovery. And I do believe, John, that we've got a little tour of the Discovery now to see.
Alright, so this is your standard cabin, equipped with a sink and a desk area for kind of doing whatever notes you need to do, and keeping clean. Resting area over here, along with a relaxation chair and some storage. If you head out through here, shared bathroom. Very quaint. And if we head out, we can go to the gym. It's a crew laundry where they wash their overalls. Also a changing room. Here we have the fitness centre. Hi. Oh yeah.
Watch that door and then aft and then up the stairs and then you're in the hangar.
Sounds good.
Alright, so what do I do? Just
Go to the right and don't step through it before it's open.
This is a watertight door. As the name suggests, it is watertight. They are quite dangerous, so it's important that when we pull the lever, we wait till the door's fully open before we step through. Door's open now, it's safe. This is the hold, where all the equipment is stored. You head on up, go to the hangar. This is our sled we put together. So this is the main lab where a lot of the equipment is linked to. So these computer screens will be showing what our equipment is doing. We'll do our calibrations and etc.
And then we can like out that. And this is through to the general purpose lab.
Yeah. So through this door is our general purpose lab. A lot of our equipment is serviced before going out into the ocean. Roller cats.
Right. Go up to the galley?
To the galley.
To the galley. Hello. Thank you very much.
You're welcome.
Cheers, Ron.
You alright, Harry?
All right.
This is the mess room. valley. Hello! There's no one here. Hi, Mark. Hi, Charlotte. Yay! It does, spotless. Where you can see people having recreational fun. Hello.
Hey. Just doing a walkthrough.
This is our DVD room. Everything is full of DVDs. Hundreds of them. It's great. All these boxes and cases, also photos. We have connection to the lifeboats. Do you want to go to...
I'm trying to think. If we go up to muster,
Up to
I think.
Munster?
Yeah. And then lifeboat.
Is there exit signs to follow? This is how you get to your muster station. Where you go and back. Onto the lifeboats. This is how you get onto the bridge.
Oh, wasn't that incredible? Did it make you want to go back to sea, Lara?
It did rather.
Well, you know, we can't do that, but what we can do is, the next best thing really is we can take you to sea virtually, because we can now join the RRS Discovery right now, live. Tell us who we've got here, Lara.
Hello, Matthew and Sarah.
Hello, can you hear us okay?
Yes. So, where are you today?
Well, we're on the RS Discovery in the North Atlantic off the coast of Scotland. And what's the name of it?
It's called the Rockall Trough.
Yeah.
Yeah.
And what science are you guys working on right now? Alberta said you've got a lot going on.
So we do. Yeah, this is a really, really neat experiment. So we're both, I'm a scientist and Sarah's an engineer. We're at a place called the Scripps Institution of Oceanography, and we're working with some people from the UK as well as some people from France and another American institution on something called the Boundary Layer Turbulence Experiment. And we can tell you all about it if you'd like us to. We've got a whole bunch of really, really specialized instruments, some of which were bought from the instrument store and some of which our group made. We specialize in making really special instruments to probe the deep sea.
Let's start with
So
what's a
that's why we're
boundary
here.
layer?
Yes, what's a boundary layer?
Yeah. You want to take that one, Sarah?
Nicely deflected, Matthew.
Sarah will answer all the hard questions about the instruments. So this experiment, it's actually kind of funny. So a boundary layer is, all we mean is it's the very, very bottom layer of the ocean. And we have some theories. Some of the theories are 60 years old about how that very bottom layer of the ocean works a little bit differently than the rest of the ocean. And that's what we're trying to prove or disprove, is this old theory. It's actually amazingly important because how the ocean actually works in this deep layer, and we're talking about 1 mile down or a kilometer and a half down below the sea surface. The way the ocean works down there actually really impacts things that affect us as a society, such things like the Gulf Stream and where it will wind up, and how that warms Britain, as well as things like sea level rise that we all care about.
And how do you, hi, Susan Morrison here. Hello, ship enthusiast. So thrilled about all of this. Hi. Although not keen on ice, another story. We've also got some questions coming in from our young viewers. I've got one question here that I'd like to ask all three of you, actually. It's from James Shaw. How long are you generally out at sea? So let's start with you guys on the ship right now. How long are you generally out there for?
Well, this trip is a 41-day cruise. And we actually moved onto the ship a week ahead of time to start setting up all of our gear. So it's almost 2 months at sea. That
is quite a lot. How long have you been at
I'd
sea
say
one time?
2 months is my sort of norm. I did a 1 month stint. That seemed quite short.
So you must have to do a lot. Don't forget, when all you out there watching, get your questions in so we can put them to the crew actually at sea of the RRS Discovery. Do you find it quite difficult to work in really stormy conditions, or are you just used to it? Do you get seasick, for example?
Most of the time, I think a lot of us are totally fine, and we've actually had great weather on this trip. I haven't been seasick in a few years, so.
Right, and same here. We actually all got a little bit seasick, didn't we? Just vaguely. When we were testing some of the instruments that we're going to use on this ship, we were on just a small, like a 44-foot, basically a boat. Towards the end of the day, we were glad to get off. Yeah, here on the Discovery, it's pretty deluxe. It's a pretty enormous ship, and she rides really well. And yeah, like Sarah said, the weather's been ridiculously nice, so it's been great.
I wonder how I can get out there. I
don't know if a lot of the kids know, though, that even so, our instruments are so valuable, and we still tie everything down, no matter what it is. And so, just in case we take a wave or the ship moves in an unexpected way, so it kind of is an interesting aspect of working at sea, is that every single thing is always tied down, and if you want to use it, you have to untie it.
And I have certainly found that when I get back on land, if something falls on the floor, I instantly step on it so it doesn't move away.
What does that go for? You've got a toddler.
So it does wear off.
So there's a question that's come in here on the YouTube. So to the crew, first of all, how do you get to be a scientist at sea?
Well, I guess I'm the only scientist, so I'll answer that one.
We'll come to engineer at sea in a minute.
Yeah, we'll do the engineer in a minute, right? Yeah. So I guess I was a kid who always loved the ocean, and when I was a kid, I didn't know that there was a subject called oceanography, and so I was going to go do something totally different. But a friend of mine had done an internship at University of Hawaii, and so when I was finishing college and applying to graduate school, I just applied everywhere he applied, and I wound up at Scripps, where I'm a professor at Scripps now, but that was for the graduate school, and it's just been that's how I got into it. And what I love about it is that we get to use our brains, and we get to use our hands, and we get to really have the feeling of doing something that really matters to society, trying to understand the ocean better, and that helps us understand the climate better.
So how does an engineer get to sea then?
Yeah, I guess a similar story on always loving the ocean and growing up near it. Like my dad was a commercial fisherman. So it's always near the saltwater. And then I actually did go to school for mechanical and ocean engineering because I figured if I like making stuff and being creative and I like the ocean, that's the best merge of everything. And then I got lucky enough to work at Scripps as well and go on sea trips where we build cool things and throw them in the ocean.
Okay, I like the first bit, and then you said you just build cool things, and then do you find that alarming, Lara? She's just chucking stuff overboard.
Well, no, I've chucked one or two things overboard myself. You do, as a rule, work quite hard to get them back again. As previously discussed, they tend to be fairly valuable. They tend to be hopefully carrying data that you spent a long time planning for and are going to spend a long time working on. So you work quite hard to get them back.
And also tie things down so they don't move.
Do.
Yes. So, what do you do the same similar sort of experiments?
So I work mostly on the solid seafloor and underneath, and they're mostly working on the water itself. There are certainly some commonalities in our equipment, particularly sort of sending things down with anchors, sending them a signal to go, please let go and come back now. And every now and again, they're there talking to you, but don't come back. And you're like, please?
Another question. Kat has said...
Just following up on the commonalities, we just last night, we're trying to sample the water, not the seafloor, but we went a little too deep with our instrument 3 times and we hit the bottom 3 times. So we went into your territory, sorry.
Did you get anything useful out of it?
It was broken.
Oh, right, okay.
Yeah. It's nice to get all the way to the bottom. We did break one of our sensors, but we got the instrument back, so it was okay.
Oh no, if you break something, do you have to pay for it?
Insurance is a
we
thing.
can't buy our instruments because we have to build them ourselves, so we just have to rebuild them when we break them.
I'm just here to get annoyed with you then. You broke my toy. I threw it overboard and I thought you were going to bring it back and you didn't. And we've got a question from Kat who says, how many people are on a ship of that size, on the size of the Discovery? How many are you sailing with on this trip?
I think there's maybe around 53 on board, something like that.
That's right around the Discovery's maximum capacity, having checked.
Yeah.
So that's
yeah, something like 22 or 24 scientists, and the rest are crew.
Right. Oh, another question. How long do you work each day? I heard that laugh, young man.
Yeah, but a lot of times we tend to take 12-hour shifts where you're not working 110% all the time, but you are constantly working on instruments or figuring out where you want to go next to do some research.
Is that how long you do?
Yeah, it's usually, depending on what you're doing, either 12-hour shift patterns or 8-hour shift patterns, occasionally in blocks of 4.
Right. Oh, there's another question. Do you work out? Oh, good question. And this is from Penny. Do you work out what you're going to do before you go on the ship? Which I wouldn't. I have to tell you.
In order to get the ship, you do have to have something that convinces people that you have a plan and that it's a good plan. But it is just an outline because there's so much we don't know about the ocean that you're always learning. You know what you're going to try to do, but you always learn about the best way to do it when you're out there. And what you find from the early results informs how you'll use the time that you have left to get the most out of it. And also sort of how your equipment is working and things like that.
Mm. So you're part of a research project then, Matthew? Is that how what you were doing when you went onto the ship?
Right. So we're all part of this large project. It's a combined United States and UK project. And so we've got 4 different science teams on board, but we're all working to do the same project. Right. And it's exactly like you said. I mean, what's the expression? It's like a plan is worthless, but planning is essential. In fact, the crew teases us every day because whenever we say this is what we're going to do, it's probably usually an hour or two, and then we change the whole plan and do something different. So, but it's really dynamic, and we learn from what the ocean is telling us, every day, and we try to do something that's sensible for the next day.
It's also essential to be a sort of glass half full person, to sort of be happy working at sea, because there will be spanners, things won't go to plan, and you have to be able to say, okay, well, we can't do that, so we'll do this. But sometimes doing this ends up being better than what you thought you would do in the first place.
So is that what drives Sarah mad? Matthew just turns up and says, I want to do the currents, his experiment, and I say, well, no, you can't do that. And then he throws it overboard and he doesn't get it back. That must drive you absolutely nuts, Sarah.
No. No, normally we get them back. We actually do pretty well with that. We put a mooring out a few days ago, and we're going to go get it. And after it's been out for a week, and we're pretty confident that one's coming back, and was measuring some great turbulence that we'll get to look at. And then the instruments that I work on most of the time actually stay tethered to the ship, where we'll do kind of like yo-yoing, where we profile it up and down to get a picture of what's happening in the water. So that they're normally closer and not really worried about losing them.
Turbulence?
And that's what's so ridiculously cool about getting to work with this team of unbelievably awesome engineers like Sarah, because that mooring is a good example. We came out here and we realized, oh man, it would be so great if we could have this one other measurement on the mooring. And so we really had to kind of work all together and design the new electronics, and design some new software, and design some new mechanical mounting. And we managed to figure out a way to get this new instrument on the mooring. And that felt really great because we all worked together to do that. So we're all excited about seeing how well that'll work.
And you do need a huge range of skills when you're at sea to have them on the ship, because particularly you guys are, by my standards, fairly close to shore. I tend to go days out, middle of the Indian Ocean. But in general, if you've not got it on the ship, you're not getting it. So you need to have the capability to build things and repair things. So all across the skill set, you need the people who can conceive of what the experiment is and how you might do it. And then you need the person who can say, okay, the actual equipment that could do this is, and then you have to be able to build the thing.
So basically you guys are NASA at sea.
Sure.
Yeah, sort of. Miniature NASA at sea.
Oh yeah, we are. Yeah, because we're close to shore, but there's definitely no hardware store nearby.
Nope.
Well, actually, that brings me to. There's a question here with you saying, because there's no hardware store nearby, but there's no McDonald's either. So someone, Shona, has sent a question asking, do you get well fed? And as a mum, I think I have to ask that. Are you well fed, Sarah and Matthew?
Oh, that is definitely not a problem.
Yeah.
There's always amazing selection of food and too many desserts.
Is that what you find too, Lara?
In general, the cooking is very good, because if you don't have a well-fed ship, everybody gets a bit grumpy, and that's not good when you're all stuck on a ship together working long days. I will say at the end of 2 months, I'm usually really eager to see some fresh fruit and veg that aren't apples and carrots.
Is that all you've got?
Well, obviously there's frozen veg and tinned fruit and stuff, but you can actually keep an apple for about 2 months in the right conditions.
And we've got a question for Sarah. Sorry, Matthew, we've got a question for Sarah. As an engineer, is there ever a moment where you just go, oh, I can't do that? Or do you like a challenge?
Oh,
don't look at Matthew.
Sometimes it's a bit intimidating, but basically we always have such a great team. My coworkers and even the crew on the ship, if we're like, hey, we kind of forgot this one part that just broke and we need to replace it. Could you help us make a different one? And so there's always plenty of support and help, and you just have to get creative.
And so another question has just come in, Matthew. It's very good. Why are you looking at turbulence? at sea?
Yeah, that's a great question. Turbulence is actually what kind of makes the ocean go round. So the water in the ocean starts out at sort of the North Pole and South Pole. It sinks all the way to the seafloor, and then something's got to make it come up to basically finish the circuit. And that's part of what we call the global conveyor belt circulation. It's the Gulf Stream is part of it, et cetera. And so where and how strong the turbulence is in the ocean is really a big part of that whole picture. And the way you can think about it is basically there's warm water up above, there's cold water down below, and you have all these kind of breaking undersea waves that lead to turbulence. And every time you have one of those breaking waves, it stirs a little bit of cold water up and a little bit of warm water down. And that helps the ocean complete its the circuit of these waters. They're kind of underwater rivers as they go around the Earth.
And that wouldn't sort of just happen because as the water gets colder, until it freezes, because water is weird, as it gets colder, it gets very slightly denser. So you've got lighter stuff over denser stuff. It's happy like that. It's stable. It's not naturally going to flip over. So you need the turbulence to mix it against its own weight, basically.
So these are underwater waves.
Hey, I thought you said you were a geophysicist. Very well said.
Is this some kind of demarcation thing? Are we having a science face-off now? What's happening? The engineer has just sat back going, woof, not doing. Yeah, she's on your territory, Matthew, but I'm on your side. Don't worry.
All of those physics courses had to be good for something. I did have to take 2 terms of fluid mechanics.
So most of us, you see, would see the ocean, the sea, as a surface and just a water that moves back and forward. So in other words, there are streams underneath going in different directions.
It's at kind of all scales because you've got what you see, and if you look at a wave breaking, it's incredibly complex. But then, as Matthew is saying, you've got this whole global cycle, which is literally the water mixing on the scale of our planet, very slowly. Doesn't sort of do it overnight. Matthew can probably tell the time scale of a complete circuit. I can't. And then you have sort of everything in between.
I see. Oh, another question. Have you seen any evidence of pollution in the seas?
The other day I did see a chunk of styrofoam float by, but not too much out here.
Yeah, I haven't seen anything. We did see some pilot whales the other day, which was lovely.
Well, actually, there is another question. It's what's the most amazing thing you've seen at sea? What is the most amazing thing you've seen? Oh, what a difficult question. I'm really sorry.
I guess, wildlife is always just great. So on the one Arctic trip, when I got to see polar bears wandering around with its cub, that was pretty amazing.
Mm-hmm.
Yeah, the polar bears in the Arctic were amazing. And then also in the Arctic, you see these thousands of different kinds of ice. Sometimes the ice freezes really quickly into little pancakes. And sometimes it's just like this, almost like a slush. And you get to see just how many different, and then of course at the big scale, then there's these huge, chunks of floating icebergs. And for me, that's amazing, just the variety of different types of ice that there are in the ocean.
Mm. We tend not to discuss icebergs, really. So it's important to keep research ships at sea.
Well,
why can't we just do it by drone?
Size of drone, middle of ocean. The drone would run out of power and go into the ocean, and you'd never get it back. However, there is a big drive to try and be able to do more fully autonomously. Because there are things, we said, we're constantly altering the plans to try and adjust, but there are projects where you need so much data, either because it's trying to map the seafloor. We actually know the surface of the Moon, Mars, and Mercury better than we know the surface of the Earth, because the water is so difficult to deal with.
Extraordinary.
Or things where you're measuring something dynamic that's happening now, like the water moving, and so you want lots of measurements at regular times. We don't have enough ships and enough time. So there is a big push to try and do more autonomously. The X Prize Foundation actually had a big challenge in the last few years for different teams making autonomous vehicles to go and map the seafloor. So things are moving forward in that direction, but that's really sort of cutting edge technology to be able to do that in a big way in the open ocean.
But right now, you're still at sea, and we've got questions come in. I'm going to ask you first, Matthew. What surprised you most the first time you went onto a research ship?
Let's see. Well, let's see. What surprised me the most? I guess what surprised me the most is that I was just a graduate student, and they were letting me actually, be out on deck and helping to recover instruments and things like that. So I would have thought that would be just for the experts, but maybe they sent the graduate students out because it was dangerous.
They literally put you in at the deep end. Sarah, what surprised you most the first time you went onto a research trip?
Was kind of funny because my first trip was a mooring recovery cruise, and so there was all these things that we were taking back out of the ocean that I had never seen before. And so I was like, oh wow, this was just down there for 2 months recording information, and we just got it back. This is amazing. It was a big surprise to see.
Just imagine pulling it out going, is this ours? Can we take this one? We'll just put it back. Sorry. And what about you, Lara?
Mine's actually a bit more pragmatic. The first time I went to sea, I was also a graduate student, quite a junior postgrad, and we were in the Indian Ocean for 2 months in the southern winter, and it was quite rough. And the Roger Revell does not ride very well. As the master said, it's slab-sided. It doesn't really have a tipping point, so you can go through really rough seas and you'll all be there at the end. It just feels like you're in a washing machine in the meantime. So it was learning to sleep braced with one arm and one leg on opposite sides so you didn't get tipped over, because I sleep on my side and it was so rough that you'd get tipped over, which isn't conducive to a good night's sleep.
It's a life skill, Lara. It's a life skill. Everyone should learn how to sleep at an odd angle. You never know when it comes in handy. I'll tell you that on the Discovery. It's a useful skill to have. If you can fall asleep in a cupboard, you can fall asleep anywhere. That's what I say. And there's another question's come in. Do you miss anything when you're at sea?
Besides my pet.
Oh.
And maybe some trees. But most of the time it's just pretty amazing being out and seeing water every day, that you just appreciate that. And then when you go back to land, you appreciate those things.
Are you the same, Matthew? Do you miss anything?
Yeah, just all the little things that happen. Yeah, for example, my wife and daughter, my daughter's 16. She just texted me today and said, "Dad, it's official. I have my first boyfriend." And
she timed that well. She timed that well. Of course,
there were all the jokes exactly that's why she timed it this way. Yeah, exactly. But no, it's hard to be away from our families being out here. It really is. But we also love. We're kind of our own little family too. Oh.
And there's another question. When you get off the ship, when you get back onto dry land, do you ever feel still seasick? Do you ever get seasick?
That's never happened to me. Maybe a little tiny bit. They call that dock rock, or at least that's what we've called it before. Sometimes you feel a little odd feeling when you first land on walk on the dock, but I've never had much of that. Mostly, I'm just excited to get to the bar.
Yeah, I guess I've only had it off of small ships.
Yeah, I wouldn't have said I ever felt sick with it, but I have definitely got off and found myself swaying. And it's quite funny if you then go out with colleagues from the ship and you realize, say, standing waiting for a zebra crossing, that you're all swaying back and forth in sync. And you haven't yet had a drink.
Yes. People going, oh, why is she swaying about? And you're there's another question is, would you recommend being a research scientist as a career? Let's start with Matthew on that one.
Yes, I mean, total dream job. Absolutely. Just how did I get so lucky? Pinch myself every day. Can't believe it. I mean, there are absolutely days when it's so hard and so frustrating, and we've had quite a few of those days out here. But just, yeah, getting to get paid for following my curiosity and answering questions that matter to the planet, and just getting to do it with amazing people and, surrounded by nature. Are you kidding me? Yeah, sign yourself up right now.
Just before I ask you that, Lara, how about Sarah? Do you think so are you like a nautical engineer? I mean, a marine engineer?
So no, that would be people who work on the engines of the ship and keep all of us afloat. But so I'm more work on the scientific equipment that we're using. For example, little sensors to measure micro temperature changes or turbulence, and instruments to profile up and down and can stay in the water for weeks at a time, hopefully working perfectly.
That's not an easy thing to do at all. Sounds like an amazing career, actually. And Lara, would you recommend?
Yeah, I would totally choose to do it again, because
even with the polar bears sleeping upside down on swaying at the bar.
But you see, I've learnt how to sleep like that now. As you said, it's a life skill. I've got it. Didn't take that long. Because it's exploration on a way that there's almost nowhere else you can do it on the planet, because we're going out to places that no one has ever been and seeing things and measuring things that no one's ever seen and trying to figure out how it all works. It's great fun.
Well, I think that we should say thank you very much to Matthew and Sarah there on the Discovery, and let Matthew go back to throwing things overboard that Sarah has very carefully crafted. So thank you so much to Discovery for joining us there. Thanks. And I hope the weather stays good for you, and fair sailing, guys.
Thank you. We really enjoyed talking to both of you, and hello to everybody else out there.
Thanks. So how long will they stay out there now?
So they've been out for a little bit over 2 weeks, and it's about 6 weeks in total that they're out. And then they'll actually, I believe, sail into Port Glasgow.
So if you're watching us and you are around about Port Glasgow around about 6 weeks time?
About 4 weeks time.
About 4 weeks time. In fact, if you go onto the website for the Discovery, you'll actually see, I think, the date for.
You can look up the date.
You can look up you can give the Discovery a wave and say, I saw you on YouTube at the Science Festival, and you can. And I'm quite sure start chatting to them. I'm quite sure they'll tell you some fascinating stuff. And the way that you've described the work that you do and the work that scientists do, it is a bit like the Enterprise, isn't it? Because it is the last frontier on the planet. It's so exciting.
You probably have to include Antarctica as well.
No.
No, you're not going to include Antarctica. It's still water, it's just frozen.
No, I'm not. I've decided. I've made the decision that this is quite definitely the last scientific frontier, and so thrilling. But how long will it take them when they've carried out all the research? How long will they wait till they get results?
It's a whole mix. They'll be getting results live as it comes in. There are some things that as soon as you get the measurement, you start plotting it up and seeing what it tells you. There are other things that you have to take the samples or take the data and go back and do laboratory analyses that either really don't like being rocked back and forth or just take far too long, or that you need to do computer analyses and modeling that just take time. Typically, going to sea, that's getting you data to work on for 3 to 5 years. And then usually it'll pick up with other projects and it'll have a tail that's even longer.
Wow. Okay, so you've been watching 70% of Water here at the Edinburgh Science Festival with myself, Susan Morrison, Lara Katniss. You joined in with your questions, thank you so much. Now, what you have to do, my young audience, is go off, swat up. You too can become a fabulous engineer or a fabulous scientist, explorer, researcher, and you can solve the mystery of the oceans. And when you do, come back and tell us. It'll be great. Thanks for joining us this evening, and I hope you join the rest of the Edinburgh Science Festival. Bye-bye.